Hello, my stats friends. So this is, okay, I'm going to be honest, it's a bit of a boring section. It's actually the introduction to chapter one, which I know would normally be your first chapter in a book, but we didn't start that way. So this is adapted from the Starnes and Tabor newest edition. I keep calling it the wrong title. I think it's The Practice of Statistics is the title of the textbook. So, anywho, introduction to chapter one, data analysis. So I'm going to be honest, it's a bit of a dry section, but that doesn't mean it's not important. There's a lot of vocabulary. So our learning targets in this section, which there's not many, we're going to be identifying individuals and variables in a set of data. And we're going to classify the variables as either categorical or quantitative. And that's going to seem like, oh, that's so easy. Well, it's maybe easy to you. Great, because that's going to be really important to us later on when we go to figure out what kind of statistics um, we need to be working with later on. Promise, it'll be important. All right, so the section that we're starting in this piece is about organizing data. And they start with the definition of statistics, which is probably the number one question I get asked when I ask kids to sign up for this class. So statistics is the science and art of collecting, analyzing, and drawing conclusions from data. And it really, truly is an art, I promise. An individual is an object described in the set of data. Could be people, could be animals, could be things. A variable, which I know you've seen that vocab word before, we're looking at an attribute that can take different values for different individuals. So a variable meaning it can change. And then when we know we have a variable, we can differentiate between what's called a categorical variable and a quantitative variable. So if you kind of break down the English root words there, categorical means that we are assigning labels that place each individual into a group or a category. And then quantitative is referring to numbers. So they take number values that are quantities, could be counts and measurements. And we'll break that down further in a moment. Actually, I don't know if it's in this section, but we'll see. Later on, we'll break that down further. So here's your straight up definitions. I think we have some flashcards that we can be working with on our e-text, so we're going to be looking at those. And that's straight out of your textbook. So let's talk about organizing our data. So we know we have possibly a variable that we can break down into categorical or quantitative. There we go. That's what I was looking for. So now the quantitative variables, the ones that take on numeracy in some way, we talked about how it could be a measurement or a count. So if it is a discrete variable, that's how we're talking about a count. It's a quantitative variable that takes a fixed set of possible values. There's no gaps, with gaps between them. So if you're taking a count of how many, socks are in your drawer, that is a discrete variable. You can't have 2.5 socks, but you can have 2 or 3 or 4. So you'll see that those are whole number values typically. And then a continuous variable is a quantitative variable that can take on anything within the interval. So you're not going to see like integer jumps necessarily. You can have measurements that are in between two integers. So, what is the temperature outside? That is a continuous variable, technically, because, you can have, well, that's a really dumb example, Abruzzo. All right, back up. Let's come up with something better. Why am I blanking right now? I need children near me. Weight is a continuous variable. So, you don't have to say like you weigh exactly 122 pounds. You could weigh 122 pounds and so many ounces and so on and so on. All right, so let's check out page 5 in our textbook with a check your understanding problem. I know the next slide will show us the solutions. So in a moment, please pause the video and check your own understanding before we flash the answer. Jake is a car buff who wants to find out more about vehicles that his classmates drive. He gets permission to go to the student parking lot and record some data. I like how he got permission. Good on him. All right, later he does some internet research on each model of car that he found. Finally, Jake makes a spreadsheet that includes each car's license plate, model, year, color, highway, gas mileage, weight, and whether it has a navigation system. Jake, you sound a little creepy, I'm going to be honest. I don't know if this is a good idea. All right, identify the individuals in Jake's study. Well, the individuals, and again, pause the video. The individuals would be the cars that were in the student parking lot. So notice how specific that was. It wasn't just cars. and it definitely wasn't students. It was the cars that were in the student parking lot on that day. So the second question, and they want us to do quite a bit of work here, so we got to look carefully. What are the variables? And then we have to classify them whether they are categorical or quantitative. So the variables were things that were different from car to car. So it was the model, which is categorical. The number of cylinders is quantitative. Um, Discrete, by the way. The color is categorical. The highway gas mileage is quantitative. That one always throws me because, like, technically the number is discrete because they don't say, like, you get 22.6 miles per gallon, but I guess technically it is. The weight, which is quantitative, and whether or not it has a navigation system, and that's categorical. You're going to have a yes, no answer. All right. Oh, apparently there was a third question. Oh, I kind of led into that. My bad. In case you're curious, there was a third question at some edition of the textbook. It may be yours, I'm not sure. But it does say that the quantitative discrete variables, that would be the number of cylinders, and they're saying the continuous variables would be the gas mileage and the weight. So, we kind of talked about that a moment ago, how gas mileage, they usually classify it in a discrete way, but it's not discrete, it's continuous. All right, let's talk about analyzing data. So variables generally take on values that vary. That's the definition of variable. So we're interested if there's a pattern in that variation. That's what we're looking for when we look at this in the frame of statistics. So one way that we could display the data to show patterns would be through some sort of a distribution. And we're going to learn all sorts of distributions in this first chapter and then throughout the statistics courses in general. So a distribution of a variable tells us what values the variable takes on and how often they take on those values. So here we have a table. It's got a lot of information on it, right? So what we have here is they're talking, what are they talking about? All right, the province of Canada. Oh no, I'm sorry. We have individuals of people. We notice what province of Canada they're from, their gender. And you'll notice, by the way, a lot of our stats data, they do just binary genders, but we now know that there's other facets to that. So just for simplicity's sake, they're sticking to binary genders. Number of languages spoken, whether they are right or left-handed, their height in centimeters, yay metric, and their waist circumference in millimeters, and whether they prefer in-person communication, Facebook, cell phone, or text messages. So one of the categorical variables is preferred communication method because they're going to answer one of the different categories that were options. So what they could then do is they could take that data and they could display it as what we know as a bar graph. So the cell phone, Facebook, in-person, text message categories are displayed at the bottom. And then up the vertical axes, we have the number of students that answered that as their preferred method. So very obvious to tell from that bar graph that most of the students, I should say the largest number of students preferred text messaging. Very few preferred Facebook. I feel like this is real data. I don't know that these are students, by the way. I don't know who they are. I didn't look carefully. All right, the quantitative variable here, we have number of languages spoken. So how would they want to display that data? Well, they could do, and you probably haven't seen these in a while. These are from when you were little kids. These are called dot plots. So the range of answers for our data went from one language all the way up to 4 languages. Not that they couldn't speak more than 4, but just the people that we surveyed only went up to 4. So when they put dots on the dot plot, it's because there's one person that answered that way. So if I look at the dots carefully, 1, 2, 3, 4, 5, 6 people speak one language in that group. 3 people speak 2 languages. No one answered as 3 languages, and 1 eager child or whoever speaks 4 languages. I'm going to guess that's an adult. Sorry, no offense to children, but typically children don't speak 4 languages. All right, let's talk about if we examine each variable by itself, then we study relationships among the variables. So what we just saw with the dot plot and the bar chart were one variable distributions. We could analyze just that variable alone. But here it's saying look at between the different variables. So it says start with graphs. Okay, cool. So we might start with graphs like that dot plot and then add numerical summaries. Okay, so we're going to see some things in this chapter. Count is an obvious one, but I think you've seen the word mean before, mean meaning average. A new one to you might be the standard deviation. Minimum is probably what you think it is, the minimum number. You might have no idea what Q1 and Q3 mean. We'll talk about that when we do the 5-number summary later on. But median and maximum, I believe you can interpret median meaning the middle. We'll talk again about that soon. And then maximum is the highest. So let's talk about descriptive statistics. This process of exploratory data analysis. Okay, let's see. Now, inferential statistics is really where we're going to go. That's going to be the bulk of our course later on. And that's why vocab is going to be so important to us. What are we trying to do with our statistics? So, inferential statistics is the process of drawing conclusions that go beyond the data. So that's a little hard for you to understand right now because you don't have a lot of experience with it, I guess. So here's the population. We know that from within the population, we can take a sample of data because either it's not feasible to get the population's information, not possible, not financially possible, whatever the issue is. So we're going to collect that data from a representative sample. We talked a lot about this in the collecting data chapter earlier about having good sampling methods. And then we're going to perform data analysis to get some descriptive statistics and then hopefully make an inference about the population if we are able to. So that's the idea, being able to take our sample, perform some data analysis on it, and then be able to extend it to the population as a whole. That's the whole point of this. So that, my friends, was your introduction to chapter 1. There's not a lot in there. The vocab there is really the most important part. And when we move on here to the rest of chapter 1, you'll see some of these things in action. All right, thanks. Hope that was a little bit helpful.